I spend a lot of time thinking about and working with UI in my career. It's one of my favourite parts of game design because it's often one of the most complicated things to get right in a game, especially in the simulation strategy genre where a lot of the game systems and mechanics end up. I really like the way that Unity has designed the majority of their UI tools. If you've ever had to code your own UI solution before, I think you'll agree that there's a real benefit to being able to visually see how your user interface looks without needing to run it in a build every time. It's easy to make adjustments and move things around, and for the most part, what you see is what you get. However, like a lot of things in Unity, it can feel pretty half-baked at times. There are a lot of common features in their UI system that are either missing completely, are mislabeled and confusing, or just flat out don't work very well at all. If you've seen the tab system or UI tweening video here on the channel, you'll know exactly what I'm talking about. So, as well as addressing some of that today, there's also a couple of pointers I feel that I can give when thinking about designing the UI system for your game. Hi there, I'm Matt and welcome to GameDev Guide. In this video, we're going to take a look at some of the best practices I like to abide by when designing a UI in Unity. We're going to look at how we can make sure that our UI is visually pleasing by defining a strict set of colors to use. We'll then explore Unity's UI layout system and how some of the components work together, and finally, we'll explore how we can build our own blur panel component to use within our UI. When we think about what's good or bad in terms of a user interface, I think we're often referring to color, style, and consistency. A lot of people think that it's really difficult to design a good-looking UI, and while I will in no way claim to be a user interface artist, I think there are some fundamental concepts you can use to take your UI from looking terrible to good with just a small amount of forethought. One of the best things you can do is look at where to draw inspiration from regarding other UI designs. Take a look at some of the interfaces you like from the games you play and figure out what works and why you like it, and maybe look at what doesn't. There's really two main trends of UI style we can look at. The flat UI design, which you'll see in games like The Sims 4, Planet Zoo, or Hitman. Then there's the more diegetic approach, placing the UI design within the style of the narrative or universe of the game. I'm usually attracted towards a more flat color scheme rather than anything super stylized, mostly because I think there's a lot of tried and tested design rules that are proven to look good in this style, so it's a lot easier to make things look good without a dedicated UI artist. I find that it's very easy to go for a stylized look and end up alienating your user through obfuscation or misjudged design ideas. So for the sake of this video, and because I think many of us are without the luxury of a bespoke UI artist, I'm going to be focusing on working with a more traditional flat UI design style. Before I get started designing a UI for my game, I like to think about the specific color palette I'm going to use. Regardless of the style you go for, you need to understand some basic color theory if you want it to look good. Do not just randomly select colors for different elements and mishmash them together, hoping for the best. This is one of the easiest ways for you to design an absolutely terrible user interface. There are already tons of great resources out there on understanding color theory. If you're looking to learn more about the topic and why it matters across more than just your UI, I highly suggest watching the Understanding Color video from Andrew Price over at Blender Guru. He covers a lot of the concepts of color theory and how it can make or break the difference between good and bad looking art. By creating color palettes and restricting the amount of colors used in your user interface, you can easily generate a sense of consistency and conformity within your game. In general, a strict color palette not only gives users a nicer time when looking at all that information, but it can also help you guide your players more easily through specific points of interest within your interface itself. Fortunately, there are plenty of tools online you can use to find and develop a color scheme for your user interface. The color palette picker from Material.io is great if you're looking for various options and shades. Paleton is also great and gives you lots of options if you're looking to explore different groups of colors, but my personal favorite, especially when it comes to choosing UI colors, is flatuicolors.com. It's a little unlike the other color palette tools as it doesn't just give you a single color palette that works. Instead, it offers a very limited selection of around 20 colors that work well together in different combinations. So it gives you a little bit of room for variation within different parts of your user interface. I'm obviously going to go with the British palette here. We can save these colors for quick access in Unity. Let's grab any component with a color property and use the drop-down to create a new library. We can choose to save it in our preferences so it's usable across projects, but let's make sure it's saved in this project so regardless of where it's open, we have access to these colors. Then let's simply copy and paste the colors from the tool and store them in our color library. If I quickly mock something up here, even with very little effort or care, you can see how by sticking to only a few predefined colors, it's easy to make something look reasonably good. So with our style decided and color palette ready, it's time to start putting some UI together and building some tools. I really like the tile-based flow of the menu in a game like Hitman or Forza Horizon. so it could be really fun to try and replicate something like that for this demo and see if we can put our own little spin on it. I'm starting with a backdrop of this low poly city screen. I've built a little random movement script here that causes the camera to randomly drift throughout the scene. I always think a little bit of motion on a menu screen is nice, so this should do the trick without being too distracting. The first thing I like to do is block out and set up the canvas space. So let's start by creating the canvas for our UI. Then let's add an image component and tint it black with a slight alpha. Let's have it stretch to fill the canvas using the anchor preset tool in the rect transform. If we hold Shift and Alt, we can set the anchors and pivot simultaneously. And let's name this panel. We're going to want to divide up our screen into two sections for our menu. We'll need a top bar for our tabs, and then a grid area underneath it for each of the options for the tabs. Let's create an empty child to our panel here. This is going to be the frame and hold our menu, so let's just scale it up to a nice size. When we're designing UI, we'll often be using combinations of layout group components. These are components that will search through the children of a game object and try to make them fit within its rect transform as best as possible. The four main components you'll find yourself using frequently are the horizontal layout group, the vertical layout group, the layout element, and the content size fitter.
But what about the grid component, Matt?
If you've ever tried to use the grid component, dear viewer, you wouldn't be asking me that question. The four main components are the secret to building UI layouts in Unity. Now, they're often incredibly confusing to understand when you start using them, but once you get familiar with them, you'll find it much faster and easier to put menus together. The best way to think about these layout groups are as nested elements of rules on how a parent and its children should be arranged. We want this menu to have a header element and a body underneath it, so we'll want to add a vertical layout group to our object here. Then, let's add two image objects as children. As you can see, if we edit our spacing here, we've now got two images stretched to fit two rows. The top row is our first element and the bottom row is our second. Let's take a look at what our layout group is doing. There's two sets of boxes checked here, Control Child Size and Child Force Expand. These labels are really confusing and actually not that helpful, so let's take a look at them in a bit more detail to see if we can better understand how they work. Let's disable the Child Control Size checkboxes for now. We'll come back to those in a bit. The Child Force Expand toggle will stretch any children to fill the spaces of its parent bounding box. So these two images are distributed evenly to fill the space. If we select the elements and scale them down, notice how they remain spaced apart. If we then duplicate them, notice how the element will try to keep them contained within itself. Essentially, this button adds extra spacing between the children to best fill a specific direction. If we disable this toggle, notice how our elements will simply stack, rather than trying to distribute themselves evenly. We should use the Child Force Expand toggle whenever we want the children to fill and space themselves inside of its parent. Okay, so with that understood, let's take a look at how the Control Child Size toggle works. Essentially, this toggle says, use a layout element to control my size. If we enable the height control of our frame here, notice how the height stretches to evenly fill the space, and if we duplicate the image again, the space and sizing of the elements are distributed to fill the frame. If we disable the Child Force Expand toggle, notice how our images now disappear. If we look, the height on their rect transforms is now 0. So when the Child Force Expand and the Control Child Size toggles are enabled, the vertical layout group will control the size of its children. When the Expand toggle is disabled, however, the layout group looks for a layout element on the child to get its data size from. If it can't find one, it will cause the height to be 0. This is where layout element components come in. A layout element component tells Unity how a specific game object should be displayed within a layout group, and allows for specific areas of our layouts to have more priority than others. If we add a layout element to our image and enable the min height, we can now see our images again. If we then set the preferred height on our bottom element, notice how it will be the only one to fill the extra space and will stop when it reaches the boundary of its parent. When inside a layout group, the layout element will assign the min height to both children. It will then iterate through the children again and try to get the child as close as it can to its preferred height with the remaining space. The flexible size setting is the relative amount of additional available space the layout element should fill relative to its siblings. I've not really ever used this effectively, but there you go. I usually find a combination of min and preferred size settings suit most of my layout needs. With all that in mind, you should now have a better understanding of the relationship between the layout components and how we can start building out our menu. We want to stretch our layout out to fill its container, so we'll enable both size and expand controls on our layout group. The first element will be our header, so let's name it header and give it a min size of about 75. Then let's tell our other box to fill the remaining space of our layout group by setting its preferred height to as high as possible. Our group will then lay out the min space of our header and assign the rest of the available space to our body area. Notice too, if we change the size of our frame here, the layout adapts best to fit the new size. By pairing combinations of layout groups and layout elements like this, you should be able to create complex menus that look good and consistent across different sizes and resolutions. Speaking of which, if we edit our game view to display a different resolution, notice how our panel size doesn't resize. This is because we're currently set to keep the canvas at a constant pixel size. I usually prefer to target a specific resolution whenever I'm designing, so let's make sure that the canvas scaler is set to scale with screen size. Now, whenever we change or resize the panel, our canvas will adjust accordingly. We can use the width height slider to better control how the scaler prioritizes the canvas size, but I usually keep it set to prioritize the screen width. So we're nearly ready to start laying out our menu elements, but there's one last thing I really want to do first. This background is a little distracting and just darkening it behind our UI doesn't look too great either. One of my favorite features of modern UI is the ability to blur out the background each time a panel pops up. In Unreal Engine, this is built into their UI system. Unfortunately though, in Unity there's no support for it out of the box, so we're going to need to build a similar component that does this for us. You may or may not know already, but we can actually assign materials to our image component in Unity. This means that we can use some shader magic to achieve the effect ourselves by writing a grab past shader. It is worth quickly pointing out that this current solution will only work using the built-in renderer pipeline. This technique we're going to use requires a call in a shader to grab a texture from the camera as the shader is being rendered. This result means that every individual instance of the shader will also cause a call to the camera. The new render pipelines in Unity don't support that anymore for performance reasons, which is fair enough, but it makes it a lot more complicated now to do something like this. I've tried finding a workaround and reaching out to Unity about this, but as it stands, there's no easy way to stack and blur UI in the new render pipelines. It's been quite frustrating for me because this is a UI feature I use a lot, and so I've actively been avoiding the new pipelines until this is figured out. If it ever changes and a similar grab pass type solution gets added, I will be sure to update you. Literally, as I record this, Unity have released a new update to their universal render pipeline to support a feature called camera stacking. Unfortunately, it still looks like it's going to make this technique a bit more complicated to pull off, as you might need a new camera for each UI element you want to blur, which doesn't really sound ideal, but that might be a good enough workaround for you. So I've posted a link in the description below to an example from Unity that might help you with that. I'll explore it myself and may make a video in the future if I can figure out a clean way to achieve the same effect in the new render pipelines. Anyway, with that cleared up, let's make our grab past blur shader the traditional way. Let's create a new shader in our project and open it up. We're going to use a basic Gaussian blur for our shader, which is achieved by essentially sampling the screen from the center and moving the pixels in a given direction from an axis. So we need to perform 3 processes on the shader to get our blur to work. We're going to grab the screen texture and blur it across one axis, then grab it again and blur it across the other, and we'll mix it with our texture and color on our component to get the final result. At the top of our shader, we'll set our main properties. The only property we really need to define for this is a blur radius amount. I usually keep the range between 0 and 4 because anything greater than that looks a bit too aggressive and causes visible artifacts. Then we'll do our first pass. This will be our initial grab pass. Due to some potential platform dependencies, the grab pass texture may render upside down, so we use this simple define here in our vertex shader to flip it the right way up. In our frag shader, we'll define a method called blur pixel that will perform our operation of moving pixels around. Our first pass will be a horizontal blur, so we'll move the pixels along the x-axis relative to our size and by the deviation defined in our method. Then we'll basically repeat this code and do the exact same thing in a second pass of the image, just offsetting along the y-axis instead. Finally, we'll add a third pass that grabs the texture and color information from our image component. Let's pop this onto a material and drop it into our image to see how it works in a bit more detail. If we open up the frame debugger, we can get a step-by-step look at how this works. You can see that the shader grabs a snapshot of the screen, blurs it one way, then grabs it again and blurs the result the other direction, before applying the color on the component. Also, if I head into our image component and select a source sprite, you can see that we can even apply other images as a background here, and if we adjust the transparency a bit, we can still maintain the camera blur underneath. So this shader gives us a lot of flexibility when it comes to UI. I know to many of us, shaders are sometimes a bit of black magic and can be a little difficult to get your head around. So if you're in the Game Dev Guide Discord, I'll be sharing the shader for you over there, just follow the link in the description below. The great thing about the grab pass shader and why the render pipeline changes bother me so much is that if we were to add an additional UI element, such as a confirmation dialog or a prompt of some sort, our blur shader will blur other canvas elements behind it. We get stacked blurring, and it's a really nice feature in modern UI. Knowing that we're going to want to use this elsewhere in our UI, it's worth defining some default behaviors for it and making our own component. So let's create a new script called blur panel. In here, we'll extend from the image component. Let's also make sure that there's a canvas group on our game object so we can fade it in and out. Then we'll add a property to define if we want the script to animate. We'll also add a float for time and a float for delay. Then in our onEnable method, because the image component runs in the editor, we'll have to check if the application is playing and set the float size on the material. So we'll just tween the value from 0 to 1 and pass in our settings on the controller here. I'm using Lean Tween, which is one of my personal favourite tweening libraries, but you should be able to do this yourself or write a coroutine if you wish. We'll then just need to define our custom blur method too. This will fade the canvas and increase the blur on our shader at the same time. Now, if we look in the inspector in Unity, we have a slight problem. None of the properties from our custom component here are showing up. This is because we've extended from the image component, and the image component in Unity has a custom editor. So we need to write our own custom editor to get our properties to show. We'll make a new folder called editor and create a new script called blur panel editor and define it as a custom editor for our blur panel script. We want the same functionality as our image script, but with access to some additional options for our blur functionality. So rather than write out a whole custom editor, we'll just extend from the image editor class. We'll draw out the default GUI and then add the property fields of our blur panel and make sure the changes get saved. Now we can see our options in the inspector. Hooray! The last few things to do are just to set the script up so that it has some default properties. Right now, our component doesn't use our blur material when we first add it, and it starts off fully white. We can select the script in the editor and define the UI blur as the default material on this component. While we're here, let's also add a nice icon for it. Then in the script itself, let's add a reset method and set the color to a slightly transparent black. Let's also add the script to the UI section of our component menu. And now, whenever we add the component to a new game object, we get a nice default blur panel. I think we're now at a really good point to finally start designing the UI layout for our menu. However, this video is already rather lengthy though, so I think we'll have to save that one until next time. Hopefully you've already got a better understanding of some of the ways you can approach designing your UI, as well as some of the concepts behind how Unity's standard UI system works. If you've enjoyed this video, be sure to hit the like button and let me know your thoughts down below. If you want to see the next part, where I approach actually laying out the menu and using some of the color combinations from our palette here, as well as me explaining why the grid system is terrible and providing a much better alternative, be sure to hit the subscribe button so you'll know when that's up. And if you're new to the channel and want to see some more videos like this, consider checking out some of the others that are on screen now. As always, thank you very much for watching, and I'll see you again next time.